Mark, I'm trying your concept here.
That'll work.
I don't know. It's so bright.
Might want to remove your badge just in case.
What?
Security badge removal.
Oh.
I'll hold it for you. Thank you, sir.
Hi, I'm Paul Tibbitts. I'm a senior staff electrical engineer here at Lockheed Martin MS2 in Riviera Beach. But long before I worked here, I worked for Woods Hole Oceanographic Institution in Cape Cod, Massachusetts as a electrical engineer as well as a pilot for the submersible ALVIN. And did that for 5 years, had 120 dives as pilot in command, and saw many, many interesting sights on the bottom, including the Titanic, the hot vents you've probably seen on television, as well as miles and miles of unrecognizable rock and mud. What brings us here today is here at Lockheed Martin at Riviera Beach, we recently got a contract with Woods Hole, which was especially interesting for me, to design the next generation for ALVIN. They call it the RHOV, or Replacement Human Occupied Vehicle. And the plan was to design the next generation, with the idea being with new technology we could make it better, dive longer, and see more of the ocean's bottom. The ALVIN that I was used to in the 80s had a maximum depth of 4,000 meters, which covers about, I think, 60 or 70% of the bottom of the ocean. The newer submarines, the French and the Japanese and the Russians have submarines now that go to 6,500 meters, and that was indeed was our requirement for the new replacement for ALVIN, 6,500 meters. And they wanted to fix all the old issues. The present submarine that's diving now continues to use lead-acid batteries. They're good for 100 dives or so before they need to be reconditioned at a lot of work for the crew. Newer battery technologies such as lithium-ion provide a capability of hundreds, if not thousands of dives before they need to be serviced or replaced. That was one of our goals. We also wanted to make it as efficient as we could. We didn't want to waste a lot of time going up and down, where basically the pilot and the passengers just sit and wait to get where they're going. So we made it more slippery or reduce its drag. Did a lot of systems engineering work. What's the optimum combination of battery power versus range on the bottom versus time to get to the bottom, time to get back, all under the overarching principles of safety. Many of the vehicles we do in Lockheed Martin are unmanned, so we don't have those concerns. But for a manned vehicle, your safety systems are paramount importance to the engineers and the companies that approve the use of such vehicles, like American Bureau of Shipping or Lloyd's, Norsk Veritas, those various organizations. So we won that job, and we went through to completion with it. Some of the images you see show how the difference is between the ALVIN that I knew back in the 80s and what we're proposing for the 21st century. And even the ALVIN that I knew in the 80s wasn't the original ALVIN. The original ALVIN went back to the 60s. It was a sphere made of steel, only good to, I think, 2,000 meters depth. And by the time I was involved in the 80s, there was only one piece of the original ALVIN still in use. It was an old electric manipulator that we eventually retired when I was there. So the name ALVIN has stayed the same, and hopefully the 21st century will see its heritage continue with a much improved, deeper diving submersible as a tool for our countries and the world scientists. Typical dive day for ALVIN on the support ship when I was there was Atlantis II. It's now the Atlantis, a newer ship. But your typical dive day starts around 5 o'clock or 5:30 with a wake-up call or an alarm clock and usually a cup of coffee. Then there's about 49 pages of checklists that need to be done before the day is over. The pre-dive checks are all done on the ALVIN, and the crew is small, and everyone chips in. The pilots also have jobs as mechanics or electricians, hydraulic specialists, and everyone is trained to do everyone else's job. But we typically stick to our specialty in the morning pre-dive. I had to do things like make sure there was fresh oxygen bottles inside the sphere. I'd check the status of the batteries, all the safety systems, the presence of safety items. Didn't want to forget the lunch and thermos bottle of coffee. While outside, they were doing various tasks with the hydraulic system, bleeding it of air bubbles, making sure enough compensating oil was in place for all our underwater systems. And usually by 8 o'clock, we would be ready to bring the passengers on board. Typically it was one pilot and two scientists. And the three of us would get in, close the hatch, and would begin our final checks as we were hoisted off the deck and lowered into the ocean astern of the mothership. Once we did a few more checks, we were released from the ship. The ship would move maybe a quarter mile away. We'd talk with a telephone to the divers that were actually detaching safety lines, final safety checks, and I remember exactly the radio conversation. It was Atlantis 2, this is ALVIN. Oxygen is on, CO2 scrubber's on, leak stumps and grounds are normal, the hatch is shut, request permission to dive. Wow, that was 20 years ago, I still remember. Then typically, almost always, we would get permission to dive. It was very uneventful. Basically, the pilot would operate a pair of switches that just allowed air to come out of the top of some tanks to be replaced by water, thus losing buoyancy, and we would slowly sink to the bottom of the ocean. Typically sank at around 25 to 30 meters per minute. So most dives that were 3,000 meters or deeper took well an hour and a half to up to 2.5 hours for the deeper dives to 4,000 meters. The whole time you're getting on your way down to the bottom, not a whole lot of science was done. Of course, safety checks were always done, a minimum of a half hour, but typically the pilot is like a good driver. He's always scanning his gauges, making sure that the oxygen's right, that the battery is up to snuff, that nothing's on drawing power that shouldn't be. Occasionally we would turn the outside lights on just to get a view of what was going past our viewports. But the best show was usually when you had no lights on. There are many creatures of the sea that bioluminesce, that is, they give off light as part of their natural body function. I personally think it's they're trying to attract a mate, and that would account for the wonderful show we would see many times going up and down in ALVIN. As we approached the bottom, we would check again with the surface, let them know we were approaching, and when we got about 100 meters off the bottom, determined usually by at least two separate methods to verify that we weren't too close, which could mean a crash landing, or too far away, which means would waste time getting to the bottom. We would drop a pair of 500-pound steel weights from ALVIN that would slow our descent as we became neutrally buoyant. And as an aside, we used to switch over to the underwater telephone and listen, especially in rocky, mountainous basalt areas. The sound of the weights crashing into the fresh basalt rocks was quite impressive, especially if it were to start an avalanche shortly afterwards, which I have heard with my own ears. Anyway, as we near the bottom, we make sure that we're neutral. That means we pump water out or take water into hard tanks to verify that we are neutral. Typically, you would stop the sub's movement in all directions and just very, very carefully sit and wait to see if you're going up or down. It's important that you don't drive around heavy all day, lose battery power, and just a clumsy way to drive around. Then it was time to go to work. The pilot sat in the center of the submarine, the observer on each side, The viewport out the front was by far the best view, and many times I have to push the scientists away if I had to do something important because they all appreciated that good view as well. The pilot was pretty busy, but safety was still paramount, always checking oxygen, CO2, grounds, things that could cause you to abort a mission if you didn't catch them early enough. Probably the hardest thing to learn as a pilot was how to properly operate the remote manipulators. But after a few dives, I think almost all the pilots were competent, if not masters, at very carefully manipulating scientific experiments, picking up samples, and attempting to catch octopus with a net, which is impossible because, as Dr. Fred Grassley once told me, Paul, they are much smarter than you. But it was almost always interesting. Some dives are much more exciting than others. Certainly the Titanic dives rated right up there with the most important. Many dives were spent in the Mid-Atlantic Ridge or other places with fairly sharp features, but still mile after mile with no signs of life or much of interest to the non-scientific operator. When it was time to leave the bottom, you would check with the surface, make sure they could accept you. On the surface, typically the only thing that would prevent them from doing that would be a typhoon that came up unexpectedly, in which case we'd be probably better off on the bottom for a day than on the surface. But same drill, we dropped the weights, another 500 pounds each, and we'd slowly rise to the surface at about the same speed that we went down. At this point, everyone has sweaters on and hats, even though it was tropical weather in the sphere when we started. On the bottom of the ocean, it's only a few degrees above freezing, and by the end of the day, the inside of the sphere is just covered with condensation, and it wasn't unusual to have 2 pairs of wool socks and a couple sweaters and always a hat, and just to keep warm. It would not be pleasant if we ever had to test the ability of the sub to support us for 3 days. I think we would freeze long before we ran out of oxygen. But hopefully that will never happen. So anyway, on our way to the surface, we apprised the mothership of our progress, and they would typically maneuver within a quarter mile of where they expected us to surface. We'd come to the surface and would soon be greeted by the splash of swimmers coming aboard to put on safety lines, close valves in case we had issues with certain parts of the flotation system, and talk to us on the telephone that they carried out with them, make sure everything was okay, took any special instructions, and as the ship came closer, they would attach the line, put us under tow. Off the stern of the ship would be picked up in the A-frame. Sometimes that was a wild ride in rough weather conditions, and set down on the deck, and lots of stories to tell after the hatch opens, and some of us had a drink right away and a cigarette. So, how's that?
Perfect.